So we're going to go take up the derivatives quiz. Now the first question is just the power rule. Right? Same with this one. So for this one, if we want to find the derivative of f at x, we're just going to take 6, multiply it in front. So 6 times 5 is 30, divided by 3 is 10, x, and then subtract 1 from the exponent, 5. Same over here. Multiply the 3 in front, so 3 times 2 is 6, and subtract 1 from the exponent. Same here, you can imagine that's exponent 1. 4 times 1 is 4. Subtract 1 from the exponent, and you get x to the power of 4, which is just 1. And you can imagine this one to be x to the 0. Right? Multiply by 0, and that's it. We're done. Okay. Now this one, it's probably easiest to first write all those radicals as exponents. So we can write 6x to the power of 1/3 minus x to the power of 2/5 plus x to the power of -1/2. Okay, so now you can apply the power rule in each situation. And we have, oh sorry, that's not g prime of x, that's just g of x. So now g prime of x, or derivative, multiply it by 1/3, so it's 6 times 1/3, right, which is just 2. X, subtract 1, so 1/3 minus 1 would be minus 2/3. Minus, so multiply by 2/5. And subtract 1, so we get minus 3/5. And then multiply by half, so we get minus 1/2. And subtract 1, we get minus 3/2. And we can put that back into radical form. So we would have 2 over x squared, and the cubic root of that, minus 2 over 5 times the 5th root of x cubed, and finally minus 1 over 2 times the square root of x cubed. Okay. All right. So this one says, again, differentiate. But this isn't a simple power rule. In this case, we have a product rule, quotient rule. Okay, and we also have chain rules in them as well. All right, so let's do the first one. So g prime of x. So first, we're going to take the derivative of the first term here. So multiply by 4. So we get 12x. Subtract 1 from the exponent is 3. And then the second term here, this bracket, we're just going to leave it as it is. This is the product rule I'm applying here. And then we're going to add just the first term as it is, so 3x4, and then find the derivative of this second term. Now to do that, we're going to apply the chain rule. So we're going to multiply by 5, and then take the bracket and subtract 1 from the exponent, and then multiply by the derivative inside the bracket, which in this case is just 1. So there you go. That's your derivative. If you want, we can clean this up a bit. So we can pull out a common factor of 3x cubed, multiply by that another common factor, x plus 2 to the power of 4, all times by 4, which 4 times 3 gives us 12, times by one of these brackets, so x plus 2 plus 5x, which just gives us 3x cubed times x plus 2 to the power of 4. And this is 4x plus 5x, which is 9x, and plus 8. So part B is essentially the same thing, except it's a lot more writing. So we're going to find the derivative here. We're going to use the product rule and the chain rule. So f prime of x is going to equal, so we're going to use the chain rule to find the derivative of this first bracket. So I'll multiply a 2 in front, times by that whole bracket. Don't change anything. Subtract 1 from the exponent, so there's just a 1 now. Times by the derivative inside of the bracket. Okay, so it's a polynomial, so we're going to do multiple power rules here. So 6 times 3 is 18. X, subtract 1 from the exponent, minus 5 times 2 is 10. Again, subtract 1 from the exponent, and then we have 5x, so plus 5. And then we have to leave the second bracket on its own as part of our product rule. Okay, plus, so the other part of our product rule, we leave the first one as it is. So 3x to the power of 6 minus 2x to the power of 5 plus 5x all squared. And now we're going to find the derivative of the second bracket, which is going to be a chain rule. So take 3 out in front, so multiply by 3, times by the bracket, 3 minus 2x, subtract 1 from the exponent, and then multiply by the derivative inside the bracket, which in this case is minus 2. So I'm going to let you factor that on your own then, and we're going to move on to the next one. However, if you like, I can write down what you should factor it out to. It's 2 times 3x to the 6 minus 2x to the 5 plus 5x, all times by 3 minus 2x squared times by minus 9x to the 6 plus 6x to the 5 minus 36x cubed plus, not many like terms in this question. What a horrible question. Minus 55x plus 15. So I didn't really make it any shorter. It took me the same amount of time. But you can factor that if you like to. But I want to focus on being able to find the derivative. So let's look at the next one. And I'm actually going to erase that just to give us some room here to do the next one, to practice the quotient rule. So the next one's the quotient rule. And we got some big ones there. So I'm going to do it here. So p prime of x. So let's apply the quotient rule. So first we're going to take the derivative of the numerator. All right, so bring the 7 out. So 7 times 8 gives us 56. Subtract 1 from the exponent. And then 6 times 2, so minus 12. Subtract 1 from the exponent. And then 4. Again, subtract 1. And there you go. There's the derivative of the numerator. And then multiply by the denominator, 4x cubed. Now we're going to subtract the numerator. Don't do anything to it. So I'm just going to rewrite this. 8x7 minus 2x to the 6 plus x to the 4 minus 1. And then take the derivative of the denominator. So 3 times 4, which is 12. X, and subtract 1 from the exponent, so squared. All divided by the denominator squared. Right, and that's it. And this one can be cleaned up too. It'll take a couple steps, so I'll let you do it. But if you want to know, it's 32x to the 7. It cleans up a little bit better than the previous one. 6, 4 plus x to the 4 plus 3 all over 4x to the 4. Okay. So next question says, find an equation for the tangent at this point, x equals 2, to this curve. So to find the equation of a tangent, we're going to need a point on the curve and the slope of the curve at that point. So we have the x-coordinate. We can easily find the y-coordinate of this point just by substituting x. So let's do that first. So we'll get y equals 3 times 2 cubed minus 4 times 2 squared plus 2 minus 3. And if we do all that, we get 7. All right, so our point then is 2 and 7. So we need the slope of the tangent at this point. So to figure that out, we need to find the derivative. So we need to find dy by dx. Yes, I'm using Leibniz notation right now. Now this one is just multiple power rules. So 3 times 3 is 9. X subtract 1, so squared, minus 8. Minus 8. X plus 1. Okay, and now at x equals 2, we can find the slope of that tangent at x equals 2 by finding out what the derivative is when x is 2. So substitute 2 in for x, and we get 21. So now you just use the slope equation for a tangent where m equals y minus y naught over x minus x naught, where these are your points, x naught and y naught, and this is m. So we get 21 equals y minus 7 over x minus 2. So you can rearrange and say y equals 21 x minus 2 plus 7, or you can distribute that and collect some like terms and you'll have 21x minus 35 if you like slope-intercept form. You can put it in standard form too if you want to. The question doesn't specify. Alright, so the last question is our application question. So the position of an object is given by s of t equals that polynomial, where s is measured in meters and t in seconds. So first find velocity and acceleration. So you'd get 1 mark for each. So the velocity is equal to the first derivative of position, which would be, all right, so minus 3t squared, 2 times 15, so plus 30, subtract 1 from the exponent, and finally minus 27. The acceleration is the first derivative of velocity, which is also the second derivative of position, which equals minus 6t plus 30. And then it says, when is the object at rest? So the object is at rest when velocity equals 0. So what we're going to do is set our equation for vt, which is minus 3t squared plus 30t minus 27. We're going to set that equal to 0 and solve for t. All right, well, I can pull out a common factor there. So minus 3 times t squared minus 10 plus 9 equals 0. And I can factor that trinomial. So you have minus 3, t minus 9, and t minus 1 equals 0. That means the velocity is 0 at both t equals 1 second and t equals 9 seconds. So part C says, when is the object moving in the positive direction? Okay, since it's talking about moving, it's talking about velocity or speed. And so we just want to know when the velocity is positive. So here I have the equation for velocity already in nice factored form for us. So minus 3, t minus 9, and t minus 1. And we want to know when that's going to be greater than 0. Now I can divide both sides by negative 3. Doing it by 3 doesn't change anything, but doing it by a negative means I have to flip our inequality. So we'll have t minus 9 times t minus 1. everything in here will need to be less than 0. So when does this occur? So you can test a few ranges. You can test any number below 1, any number between 1 and 9, and any number greater than 9. If you look at any number less than 1, well, this bracket will be negative and this bracket will be negative. Negative times negative is a positive. That doesn't fit our inequality there. What about any number greater than 9? Well, if they're both greater than 9, you'll see that both brackets will be positive, and again, does not match our inequality. However, if t is greater than 1 and less than 9, then our first bracket here is negative and our second bracket will be positive. Negative times a positive is a negative. That fits our inequality. Therefore, the object is moving in the positive direction between 1 second and 9 seconds. Part B is a similar type of question, or part D, sorry. At what time is the acceleration positive? So here we have the equation for acceleration. We have minus 6t plus 30, and it wants to know when this is positive. So when is that greater than 0? All right, so we have a common factor. We can pull out negative 6, which is t minus 5. When is that greater than 0? If we divide both sides by negative 6, because there's a negative there, we're going to need to flip the inequality. So we would get t minus 5 must be less than 0. And if t minus 5 is less than 0, again, test it. When is this true? Well, it's obviously true when t is going to be less than 5. There you go. That's it. All right, so E says draw a diagram. Okay, our entire next unit of calculus is going to be curve sketching, but we can do something simple here. First, what we can do is notice that s of t, when t is 0, all these terms go away except for the last one. So we're going to start, if this is time 0, right, time and position, we're going to start at 11. All right, so what else do we know here? Well, we know at t equals 1 second and t equals 9 seconds, the velocity is 0. Okay, so if the velocity is 0 at those points, that tells us one thing. That tells us if the velocity is going to be 0, then the slope of the tangent on our position is horizontal. Right? So it could be something like this, or it could be something like this. Okay, it could open up or open down, but in both those cases, we have a horizontal tangent where velocity is 0. So that's going to happen both at 1 and at 9. Okay, so what else do we know? Well, we know in between 1 and 9, we're moving in the positive direction. And we know that the acceleration is going to be positive if time is less than 5. So we put a 5 here. Okay, so it can look something like this. And this is going to go quite high up until it gets to 9, and it's going to curve back over. Like that. Yes. So yeah, once again, the last question, just going to change it since it's a 1-mark question. Determine where you are at 12 seconds. That's just the picky physics teacher in me. Total distance would be adding up everything. So just put in 12 in for S, and you'll get 119 meters.